Hello, everybody. So we are now doing chapter 3. So this is in your workbook. This is exactly what you see on your workbook. If you open up to page 120, uh, bear with me, 124, you will find this. So I've had questions about, do I use the workbook stuff? Yes, you can write it in here. I know module 1 and 2 are a little bit different. Going forward, everything here is in the workbook, however. That said, it also contains some answers. So, what I recommend you try and do is make those things invisible. Literally, like cover them up with your hand while we talk about it. I will occasionally be writing notes in here as well. Yeah, I highly encourage you to do so. All right, so this is about surface area, volume, and capacity. And we're going to be starting out here with the volume of prisms. So when we look at prisms, prisms are a, ooh, I think that black. Prisms are a 3D object, right? A 3D object, so this is a square, is just made up of a bunch of 2D objects. Oh, this is a square. This is a square. This is a square, so on and so forth. So we need to understand how to find the area of squares, rectangles, parallelograms, triangles, and circles. And you can find those here. Now, so the area of a rectangle, and this is true for a square as well. If you're not sure, just default to a rectangle. A square is a rectangle. A rectangle is not a square. So just default to a rectangle. I apologize, there's a train in the background. I'll do my best. So a rectangle is just length times width. This sucks to write every time. So instead we say, hey, the area is the length times the width. And as you remember, how we denote this stuff here. If I said this one is 5, it has a width of 5 and a length of 10. Oh, it's 10 times 5. Here, let's say centimeters. No, it is not 10 plus 5. It is actually, so, it's not just 50 centimeters. It is 50 centimeters squared. We denote area, surface area, the measure of space of area that an object takes as squared units, right? This squared just means it's a centimeter times a centimeter. So it's a really small detail, but you always want to make sure you're keeping track of that because I promise you later in the course, it's going to cause an issue if you're not. So again, I'd recommend just squares don't exist. Treat everything as a rectangle. Your life gets easier. Now, a parallelogram is a little different. It is base or length times height. Now, look at what I'm doing here. Height goes straight up. It is a pure vertical. The blue line here, this is not height. This is the most common mistake people make. So it is base times pure height that goes up. Now, what the hell is a parallelogram? Well, isn't a rectangle just base times height as well? Yeah, you're right, because a parallelogram is technically just a square. This shaded in region here, that on the left side, is the exact same as the shaded in region to the right. All I did was I cut it and I moved it. So it's the same thing. Now, a triangle is base times height. So just like a parallelogram, oh, it's the same thing, but I cut it in half. It's half times base times height, right? So times base, let's say the base is 10 and the height is, I'll use 5 again. Well, 10 times 5 is 25. Half of 25 is 25. And we'll say centimeters and it's squared. So the reason behind this is that a triangle just is half of a square. Is essentially how it works. You don't need to understand that, but you do need to memorize this equation. You do need to understand how to do this. So again, this is base times height, this is base times height, and then a half. Now a circle is pi. We call this little symbol here pi. Now this has a number value. On your calculator, you will find that button. I want you to actually take your calculator and find it now. Pause the video. So pi on your calculator can be found here on the top right section. Just this little symbol. You press enter. Oh, it's just pi, right? Well, you change it, you can give you the decimal. Pi goes on forever and ever and ever and ever and ever. So we usually just try and keep it as pi. Now, eventually, though, you can times pi by a number. Let's say it's by 10. it'll give you a number value. So it technically we say it's like 3.14, but your calculator can do the heavy lifting for you here. So when we're looking at this thing here, the area of the circle is pi, right? Pi times radius. It is radius squared. When you see, again, this little 2 here, this is saying that, hey, this is r times r. So if I tell you that, hey, the radius of this circle is 10, what you're putting in your calculator is one of two things. There's one of two things. You're either going to put in pi times 10 centimeters times 10 centimeters, or two, you're going to put in pi times 10 squared centimeters. So you're putting either of these in, and it gives you the exact same answer, right? So it's pi times 10 times 10, which is, so the total area of the circle is 314.15 centimeters squared, or pi times, how do I do that little squared symbol? You don't you don't have to do it, but you could just use this X2 button. This is squares this on here. So you could use this little X2 button where my mouse is. So same thing here, okay? So very important that you know that. And then finally, we call this a trapezoid. So for a trapezoid here, it's kind of complicated. Actually, sorry, before I go to the trapezoid, I want to talk about this circle here really quickly again. I'm going to erase everything here. You're going to need to write more notes down for the circle. If you're not writing anything down, you should go back and write this all down. So this next part here is, so we have what we call a radius, right? We say that's r. Now a radius is half of the circle's width. If you're looking at it, this little dot here, this is the center point, and then the radius is just that center point to an edge. Now we also might have a diameter. Now the diameter is a little bit different. A diameter, which we say d, is two radiuses, two r's. It is the full circle width. Sometimes you are going to be given a circle where they say, hey, this whole thing here is 10 centimeters. But you don't care about the whole thing. You care about the radius. So you would have to half that and figure out that the radius is 5. So that is a very important thing to know, is you need to figure out what the radius is. Read the questions carefully in this unit. The next thing here is, so moving on now, is a trapezoid. Trapezoid's a little bit difficult. It's pretty freaking hard. So trapezoid here. So again, you have your height, and again, I call this the pure height. You have the base, which is the top length. You have the I don't know, the other base. They're using A here, which is the bottom length. So it's a half times, you add these up. Let's say if this is 10, this one's 15, it would be 25 times the height, which we'll say is 5. Again, so it'd be a half times 25 times 5. It's 62.5 in this case. So just making sure that you are doing that here as well. So what you want to do here is, I want you to calculate these areas. Now, below are the answers. Just cover them up. Again, put like a piece of paper. Don't look at them. Try and do them. 3, 2, 1. Okay. The answers are there. Again, length times width, 6.8 times this. B, it's a triangle, 7.8, 12.8. Sometimes they'll give you 3 measurements. Sometimes they'll give you, I don't know, this is a 15 here. You wouldn't use this. You care about just the pure height. And then this is a, what's the word for it? Parallelogram, base times height. So for this one here, little bit different shapes. So first thing I need to do here is I need to, one, name the shape, two, calculate the area. This one's pretty easy. It's a circle. It's a circle, right? Now, question two here, however, well, what's the area? Now there's steps for success. Your first step is put the blank, put the formula. What's the shape? What's the formula? Okay. So in this case, it's a circle. The area equals pi times r times r. Pi r squared. Right? Or pi r squared. Same thing. These mean the same thing. The next thing you need to do is you need to substitute. This is what good work is going to look like. This is what I'm going to be checking for. So your area equals, again, pi times the radius, which is 44 millimeters, times 44 millimeters. And then the third one is you need to solve with proper units. Okay? What does that mean? Proper units. Your area is equal to, where's my calculator? Again, pi times, I'm going to go 44 squared, right? That little squared here is the same thing as times 44. Just showing you how to use your calculator. Change it. 6,082, we'll just say that. 6,082 millimeters. Proper units. Oops, squared. My final answer, I'm going to circle it. Right? So you have steps for success here. You need to be doing this for all of them. What do you mean? I have to show my work. Yeah, I know it sucks. But again, you're coming back to this in 4 months. You're not going to remember this 4 months from now. You're not that guy. Don't get an ego over it. Just do it. It's a couple extra minutes throughout the entirety of the course. You learn it better. That's why your markings are worth a lot of marks. So your working's worth marks. So question two, obviously it's a triangle, right? So now you're noticing, well, okay, so steps to success, okay, it's a formula. The area of a formula was a half times base times height. Step two, substitute. My base is 9.3 meters. My height is, 6.2 meters. Wrong. Height, the height that goes pure up, 5.7 meters. 3, solve it. Again, half or 0.5, same thing, times 9.3 times 5.7. 26 point, we'll say 5. 26.5. What's my proper units? Well, it's in meters, and it's area, so that means it's squared. Question C, find the area of this. What is this shape? Well, you guys can physically rotate your booklet. I can't do this, I have to pick up my laptop and spin it around midair. But if you're ever not sure, you can do that. Figure it out. That's totally fine. But in this case, this one is a parallelogram. So, area of a parallelogram. I don't remember. How can I find out? Go back to page 125. Oh, it's base times height. So, area equals base, B times H. Or you can just write A equals BH. That's fine. That's shorthand. I know what you're saying there. My base is 14.8 centimeters. My height is it 6.9? Is it 5.3? It's 5.3 because it goes straight up. 5.3 centimeters. 14.8 times 5.3, 78.44. 78.44 centimeters squared. Now, question D is a triangle, obviously. Area equals base times height. My base is 16 inches. My height is 9 inches. You're right. It's the one that goes straight up. You multiply those together, you're going to get 72 inches. Now, I'm getting a little sick of using this pen thing here. So sometimes you might see me do this. 72 inches. I put a little, this thing here. This little thing here just means it's to the power of. In case you ever see this in computer notation. I will almost always stick to like this one on the left here, but just so you know, knowledge is power. Why not? All right. Now, I'm going to trust you guys to be able to do this for question 2 here. These are all the same things. Nothing here is different. It's all triangles, squares, or rectangles, and parallelograms. What I am, however, going to go do is move on to example 2. I want you to literally cover up the answer below. Take something covered up. So, obviously, why is this harder? Well, we call this a composite or a combined shape. It's a complex shape made up of simple ones. So I do these same steps up here, but I need to divide it. Now, one thing I really want to note here is that, and I want you to write this down, keep organized. Some of the questions that you're going to be doing are going to be 10 minutes long. You don't have that short-term memory. No one does anymore. All of our brains are rotted. So you need to keep organized. And the first thing you need to do is I'm going to separate the shape. There's a couple ways to do this. One is I could separate it like this. Oh, that's a rectangle. And oh, here's a triangle and here's a rectangle. So I could go, here's shape 1, 2, and 3, right? So keep organized. What do I mean by that? Well, the area is equal to the area of 1 plus 2 plus 3, right? So what's my area of shape 1? Well, this is a rectangle, so it's area times base times height, right? So A equals B times height. My base in this case is, I don't know yet. I'm gonna skip that for a second, but my height is 6.8 centimeters. I'm just gonna put centimeters because I don't have a lot of space here. I'm gonna skip the centimeters because I don't have a lot of space. Now my height. Sorry, my base. My base is the length of this thing here. The length of this red line is the same as the length of this red line, right? So I know that this whole thing is 13.4, right? And I know that this part is 13.4 minus this part where my mouse is, which is 6.2. Right? So 13.4 minus 6.2. Well, the entire length of this then is 7.2 centimeters. So that's where I'm getting 7.2 from, is I literally took the length of the whole line and I separated out what I know. You take what you know to find out what you don't know. That is math in its premises. That is the entire course right there. So shape 1 is 7.2 times 6.8. We will round exactly as 2 decimal places in this case. So the area of this one is 48.96 centimeters squared. Okay, so that's shape 1. Check. Keep organized. I know this seems lazy and like redundant, but like you're going to be given some pretty difficult stuff in this course eventually, and you're gonna mess up because you did the math right, but you just goofed up which numbers and stuff. So keep it organized. So shape 2 here. Now rectangle is base times height, right? My base in this case is, we know it already is 6.2. My height is, crap, what's my height? Well, green line here. Your height, ooh, no, 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 keep that red. Um, Green line here is this, right? Well, I don't know the full measurement of that, but I do know that this part is 6.8, and I know that this part is 3.1. 6.8 plus 3.1, 9.9. So 9.9, and I'm actually going to literally write that out here as well. Keep it labeled. Okay, 6.2 times 9.9, area is equal to 6.2 times 9.9. 61.38. Area equals, sorry, 61.38 centimeters squared. Now my next shape here is a triangle, right? Triangle, area equals a half times base times height. My base is 9.9. We already calculated that. My height is 12.6. It shows us down below. So a half times 9.9 times 12.6, 62.37. 62.37 centimeters squared. So now I have one, I have two, I have three. All I got to do is add them up now, right? The area equals 48.96 centimeters squared. I'll add the square in a second. Plus 61.38 centimeters squared plus 62.37 centimeters squared. So all I got to do is add those up, which you can find down here, or 172.71. So the total area is 172.71 centimeters squared. A lot of numbers on this screen, right? Start circling your answers. So organization is important for this. Now, as you can see, we did this different than they did down here. They did the triangle, this top rectangle, like they did split it here, and then they did this. There's going to be multiple ways you can do this. Pick the one that works for you. It doesn't really matter. There's a couple ways to do this shape. Okay. So I want you to work on these ones here. Now, okay. So I want you to work on these three. Pause the video, work on them right now. In about 5 seconds, I will have the answers on the screen. I won't walk through them all, I'll just have the answers. So 3, 2, 1, pause, pause, pause. Okay, so now that you've unpaused it, I'll do a quick walkthrough. Again, I've split this up into two shapes. There's two different ways of doing it. I did it this way. Do whatever one works for you. But either way, answers 128.5 centimeters squared. For question 3B, again, split this triangle up. Now, the base of this triangle is 4.2, as we can see here. And the height of it is, well, the whole thing's 9.6. Just the rectangle part's 7.8. So I get 1.8 if I subtract those. So area 1, 7.56. Area 2, 32.76. Add them up, 40.32. For section 4, you're going to notice I have four shapes. You don't. I copied and pasted it. Lovely part of being on a computer. You could do it a couple ways. You could draw the lines in there. You could recreate the shape. I don't care what. The whole point here is showing that all four of these areas work to find the total area, which is 45.9 meters squared. Oh, I don't need the line. Go away. 2. So either of these work. Any of these work. Now this next shape here is, okay, we're done with we're done with 2D shapes. Now we're moving on to 3D ones. So we call 3D shapes a prism. These have bases and faces. So a prism is a 3D shape. A base is one of the faces of it, and so on and so forth. So we have a couple of prisms here. Now this one, how do I name stuff? Well, look at the face of it. That is a rectangle, which means it's a rectangular prism. Look at the face of question B. That is a 1, 2, 3, 4, 5, 6. 6 is a hexagon. So it's a hexagonal prism. Question B is a triangle, obviously, which means it's a not a triangle prism, triangular prism. Question B, well, that's a rectangle. You could put rectangular prism and that would be fine. Technically, it's what we call an oblique one, but as you can see down here, but like we're not getting that fancy. So I'm just going to give you the answers for these in here. So I'm gonna be really clear here before I actually no, I'll just give you the answers here. So 3, 2, 1, work my magic. Boom. So here they are. Now that said, number A, triangular. You could just put like triangular prism. We don't really care about whether it's right or oblique right now. So I'm just gonna get rid of those. Actually, I'm not gonna actually get rid of him, but like, we don't really care too much about that stuff. That said, I'm not gonna ask you to like know that much about 3D shapes and like what's a hexagon, so you will need to know this. You will need to know a hexagon is 6 sides, an octagon, right? Octopus is 8 sides, a decagon, decade is 10 sides. These are ones you are going to need to know on top of the basic shapes like triangles, rectangles, pentagons, trapezoids, circles, stuff like that. So those are things you're going to need to know. But the name is not too important. I'll give you guys as much information I can out of that. This isn't meant to be a, can you recognize what shape it is? That's not the point purpose of this unit. So the next thing we're going to be doing here is nets. So a net is a 2D pattern that I can fold into a 3D shape. Think about a pizza box. It's made up of one piece of cardboard, but if I fold it up, it turns into a 3D shape. Nets are used specifically a lot in cardboard. And so, give you an example. Let's say I order a package off Amazon. It comes in a box. This is the net of what that box looks like here, right? Here's a rectangular prism. Well, I can say I have the base or the bottom of it. I have a top. I have sides, and I have a front and a back face. So it's turning a 2D object into a 3D object, or a 3D object into a 2D object. And there's a couple ways of doing it. Here's some more examples here. As you can see, though, they are attached. This is a little bit of it takes a little bit of practice. If you're really good with like visual space, you'll really excel in this part, but you do need to know what a net is. Again, another example, this one's a little bit color coded. I'll put all these images up there, but really important to know. You look at a cylinder or a can, it's 2 circles and a rectangle. What? What do you mean? How is a can, I don't know, a can of beans, a can of corns, how is that a rectangle? Well, it is. It's just a curled up sheet of metal. So those will be all available on your on the front of the course here. So so if I were to lay this part out flat here, now you can see it down here, but I'm going to kind of give you some instructions here. So the first thing you're going to start out here, because people struggle with this, if they're not too great with like visual space, is start with the bottom, right? This here is the bottom in this middle part here. So I start with the bottom. Okay, it's because it's invisible, but it is there. Then I need to move on to the front and back faces, right? What's the faces? Here is the back face. Here is the front face. You can label those as back and front. That's fine. Then I move on to the sides, right? I have a right side, I have a left side. Here's my right side, here's my left side. And then in this case, there might be another side. In this case, this would be maybe this is like a top. Actually, yeah, we put a top in this case. So this would be my right top. This would be my left top. So you just want to like build it out from there, right? Start at the bottom and build it out. If I were to fold this shape up, that's what it would look like. Now, I do want to note here is a couple things. Look at how they've labeled this stuff here. Like the whole thing's 50 centimeters. How did I get 50 centimeters? Well, what I'm highlighting is the same thing, right? Oh, this line is 10 plus 10 plus 10 plus 10 plus 10. The whole thing's 50. And then this part here they didn't label is 30. So it's a little bit of a skill, but you'll get there. Take some practice sometimes. There's going to be a net assignment that you'll have to do. So we're going to try drawing a net for these in this case. So again, what do I start with? The bottom. And I recommend you draw small here. So I'm going to start with the bottom here, right? So we're going to say shore. So I've done the bottom, check. Now I'm going to start with the front and the back faces. These things here. Now, sorry, which one's the face? Is it A or is it B? It's B. These are the faces. There's only two of them. Whereas A, there's one here, there's one here, there's one on the bottom, there's one on the back side. So I'm going to start with B, which is a square, 5 by 5. That's a square. Now I'm going to do the sides. So I've done the bottom. Now I have this side and I have the back side, right? So there are two sides there. And then I start with the top, which is another one. Now, how do I know if I've done it right? Well, how many sides are there? There's 1, 2, 3, the back side, 4, the bottom side, 5, the right side, 6, the left side. 1, 2, 3, 4, 5, 6. I'm good to go. No, I'm not. You need to label the stuff. This one's 5, this one's 5, this one's 5. This is 15. How wide is the whole thing? I want you to think about it, actually. How wide is the whole thing? Well, it's 5 centimeters tall. That's how long this part is. So 5 plus 5 plus 5 plus 5. The whole thing is 20 centimeters wide. How tall is the whole thing? Well, 5 plus 15 plus 5 is 25 centimeters. You try. Try question B, right? How many sides are there in total? Then start with these steps. So pause the video. 3, 2, 1. And here's what it looks like, right? I have my bottom. I have my back face. I have my front face. I have my right side. I have my left side. And it's a triangle. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Wait, what's going on here? Nope, I counted it wrong here, right? Think you don't count like the sides here and then think, oh, left side, right side, bottom. No, there's a bottom side, there's a right side, there's left side, and then there's the front face and the back face here. 5 shapes in total. Now, did anyone catch the mistake I just made? Read the question again carefully. Draw nets for the prisms, check, and then label the dimensions of each side. Check. No, I haven't made a mistake. That said, we should probably find the surface area of them. And I want you to do that. Find the surface area of shape A and shape B. 3, 2, 1. And here they are, right? So I know that this side here was 5, right here. So 75 times 15, 75, 75, 75, 75. These are all identical, right? And then I know that these faces are each 25 each. So you add this up, you get 350. Oh, I made a mistake. Not centimeters, it's inches squared. Question B, 42 plus 42 plus 42, right? 14 times 3, that's the length of this side here. The faces are, now you may have done a 3 times 3. No. The base is 3, but the height is 2.6. So the area of each triangle is 3.9. So you add these up, you get 133.8. Now, question 7. Ralph says that diagram A is the net of a right octagonal prism. One person disagrees, Manon. She says that diagonal B is the right net for a octagonal prism. Who is correct? Justify your answer. I want you to think about it. I want you to spend a literal minute, think about it, and explain your reasoning. Literally write it down. So 3, 2. So an octagonal prism, what would that look like? Let's actually try and draw it ourselves, right? What would that look like? Octagonal, 8 sides. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So that's what an octagonal prism, like that would be the face of it. Then that means that there's one side, which is the face. There's 2, 3, 4, 5, 6, 7, 8, 9 sides. Then there's a bottom. So there's a total of 10 sides here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so maybe A. 1, 2, 3, 4, 5, 6, 7, 8, 9. A is the correct answer. So how would I respond here? Ralph is correct. Manon's net is missing one of the sides. I'm sorry, and then example 5 here was you just want to draw a net of it. I trust you guys who did this earlier. I'm skipping past it, but here's an example of it. Okay, so at this point, I feel confident enough to let you guys go. I do, however, want to talk about this one here really quickly. Pay attention to what this shape is. As you can see, the length of these lines here is 1.5 as well. So just do keep that in note here. I am going to go straight to example 6 here, which is a net. It's a 3D object, but now it's gone to one of those composite or complex shapes here, right? Now we still do it the same way. We still gotta do it the same way. But the big thing here is you need to freaking keep organized, because now I've taken this, which is already a bit of a task, and I've applied it to a 3D shape. Blah. This is going to be difficult. So it's important to keep organized. I still start with the same way. I'm going to separate my shapes like, I can either do it like this, or I could do it like this. Which one do I want? I'm going to do this. I'm going to do top and bottom shape. So keep organized. Here is shape 1. Here is shape 2. Now, write your little formula here. What do I mean by formula? Well, the surface area is equal to shape 1 plus shape 2. Simple enough. But shape 1 is equal to what? It's equal to the front and the back side, the top, no bottom, and the right side and the left side. So 1, 2, 3, 4, 5. It's 5 shapes added together, right? And you're noticing I'm excluding the bottom. Why? Because there isn't a bottom. It's in the shape. So it's the top plus the front plus the back plus the right side plus the left side. If you do not do this organization, I promise you're going to get it wrong. I know it's like, work, but you got to do it. So shape 2, I'm going to use blue in this case, is ooh, I've run into an issue here, haven't I? No, not quite. I can still do it this way. Front, back, right side, left side, the bottom, and the top. The only difference is the top's a little weird here. The top and bottom are not the same shape. So it's the front plus the back plus the right plus the left plus the top plus the bottom. Now, for shape 1, the front and the back are the same size. The right side and the left side are the same size. For shape 2, the top and the bottom are not the same size. So you just got to keep careful of that. This forces you to think about it. So, okay, I've done this. Now I feel like I can confidently do this. So let's do shape 1. The front is, well, how tall is this part here? This part here, well, the whole thing's 55. If this part of it, so this line's 30, that means this line's 30, which means this line's 30. 55 minus 30, oh, it's 25. So it's 25 times, how long's this part here? Well, if the whole thing's 78 and this part of it is 45, well, 78 minus 45 gives me 33. So very difficult to do, right? This is why you got to keep organized. So 25 times 33. The front is, where's my calculator? 25 times, ooh, not plus. Again, everyone makes mistakes. 825. So 825 centimeters squared. Is the back the same in this shape? Yes. So in this case, the back is also 825 centimeters squared. So let's do the top. The top is 33 times, how long's this side? It's the same as this side, which is the same as this side, which is the same as 27. Do you see how I'm doing that? Now, if you struggle with that, you can literally take a ruler. Can I rotate it? I can't rotate. I need a touch screen. You can literally take a ruler and you can just straighten it on this edge and then move it the same side. These are all parallel sides. But anyways, so the top here is 33 times 27. 891 centimeters squared. So what's left? What's left? Again, keep organized. I've done the front, I've done the back, I've done the top. Now it's the right side and the left side. My right side, which I can see, is, well, this is 27 times, what's the height? I know it's 25. So 27 times 25. Yeah, I did that same thing, right? You gotta always pay attention. 675 centimeters squared. Now, is the left side going to be the same? Yes, it is. So it's also going to be 675. Now, is the bottom the same as the top? No, there is no bottom, right? It doesn't count. It's embedded in the shape. So shape 1 is done. So all I got to do is add these up. 825 plus 825 plus 891 plus 675. $3,216 centimeters. So 3,216 centimeters squared. I'm going to circle that. Now you might be asking, oh, but Matthew, you didn't show your work. Didn't I? Up here, this is adequate work. If you have these numbers here, I'm going to know how you got to 3,216, okay? But I do recommend that you do this here. Like don't do the math. Don't actually write down 825 plus 825 plus 891. You can if you want, but I do want you to be shown this type of work up here. So let's do shape 2 now. Now shape 2 is 6 sides. So let's start with the front. Well, the front is 75 times 30. 70 times 30, 2,025 centimeters squared. Now, is the backside going to be the same? Yes, 2,250 centimeters squared. Now let's do the right side. 30 times 27. It literally tells us. Now that's the same as this part up here as we did before. So I already have that calculation. Wait, no, I don't. Okay. Um, so 30 times 27, 810, right? So 27 times 30 gives me 810 centimeters square. Left side. Is the left side going to be the same as the right side in this case? Yes, it is. Top. So the top, well, this line here where my mouse is 27, and this one here is 45. So it's 27 times 45. 1,215 centimeters squared. Bottom, I'm putting BO here, right? Is the bottom going to be the same as the top? No, the bottom's different. The bottom here is 78 times 27 equals 2,106 centimeters squared, which means shape 2 is equal to 2250 plus 2250 plus 810 plus 810 plus 1215 plus 2106. 9,441. Wow, it's been 5 or 10 minutes already. What was the question? It wants you to find the surface area of the surface. So I have shape 1 and shape 2 done, right? So go back to your original equation. So the surface area is equal to shape 1, which is 3,216 centimeters squared, plus shape 2, which was 9,441 centimeters squared. If you add those up, you should get 12,657. A lot of text on here. I'm going to square or circle it or do something. And you notice how I labeled, like I organized even what my answer for shape 1 was. It's fine to circle or square multiple things, right? But you're just keeping a note, like these are the important things. So this was a lot, wasn't it? If you didn't keep organized, if you just put random crap over here and over here and over here and over here, you're not going to get it right. You need to organize yourself for these complex questions. So again, there's a couple of ways here. They did theirs different. They cut theirs in half like this. You can do it that way. It gives you the same answer at the end, right? Um, okay. So I want you guys to do the rest of these questions here. Now, one thing I want to note is question 9. You got to take away this part here, right? That's invisible. Question 10, you got to take away these parts here. They're invisible. So you just got to keep a note here of how you're going to separate this. Okay. There's a lot of stuff here to be able to do, right? So I'll let you guys get into this. This is a really beefy part, and I do apologize. The rest of it is going to get a lot simpler. This is by far the hardest part of it, just because there's so much information. Break it up over multiple days if you need to. That's fine. If you are struggling with this, though, you need to get in contact with me. Okay, so I'll let you guys go into it. Take a look at the assignment parts of this. Perfect. Thanks for your patience.